I'm Dr. Sreekanth, Professor, Department of Data Science in Institute of Aeronautical Engineering. So we're concentrating now, Module 2 is the relations, functions and lattices. So these are the syllabus, and the prescribed textbook is Tremblay and Manohar, Grimaldi and Dr. D.S. Chandrasekharaya. Now, relations. So whenever if you are going to give, we are going to connect, we are going to combine two sets with some relation. So let us consider A is one set and B is one set. So set A is consisting cities, that means we have to consider the cities like Calcutta, Patna, Lucknow, Chennai, and B, set B is consisting the states West Bengal, Bihar, Uttar Pradesh, Tamil Nadu. Now there is a relationship between the elements of A and the elements of B. One set is consisting cities and another set is consisting states, and there is a relationship. There is a relationship. What type of relationship will be? So Calcutta is related to West Bengal, Patna is related to Bihar, Lucknow is related to Uttar Pradesh, Chennai is related to Tamil Nadu. Now, whatever the relation will be there, those elements we are considering in the form of ordered pairs. So, one is Calcutta, West Bengal is one ordered pair, and Patna, Bihar is another ordered pair, Lucknow, Uttar Pradesh is another ordered pair, Chennai, Tamil Nadu is another ordered pair. So here, the first one is the capital of the second one. The relation is, first one, Calcutta is the capital of West Bengal, Patna is the capital of Bihar, Lucknow is the capital of Uttar Pradesh, and Chennai is the capital of Tamil Nadu. That means the elements are related. The relation is capital of. So now we are going to generalize the relation as X ordered pair, X comma Y, such that X belongs to A, Y belongs to B. That means the first element member in A, the second element member in B. So the relation we are going to represent in the form of ordered pair. Or we can say that X is related to Y like this. X is related to Y. And X is related to Y. So like this. So we are going to say X is related to Y, we can write, or else X comma Y is an element in the relation. X comma Y is in the element in the relation. So now let us consider the definition of the relation. Let us A and B be any two sets. A relation A from B, A to B, is a subset of the Cartesian product of A cross B. Subset of the Cartesian product of A cross B. So R is a relation. Relation is nothing but a set of ordered pairs. So of course it is having all the ordered pairs of A cross B or some ordered pairs of A cross B. So here let us say what is the Cartesian product of two sets. What is the Cartesian product of two sets? Suppose A and B are defined as like this. Then the Cartesian product is 1 related to 2 and 1 related to 4. Next 2 related to 2, 2 comma 2, 2 comma 4. Next 5 comma 2, 5 comma 4, like this. So this is the Cartesian product of two sets. So in that, we are going to consider a relation. A relation is nothing but any subset of this. Any subset of this. Or the entire set is itself a subset. So now, suppose R is a relation from A to B, then R is a set of ordered pairs AB, where A belongs to A, B belongs to B. Every such ordered pair is written as A related to B and is read as A related to B by R. A related to B by R. See, A comma B does not belongs to R, the set does not belongs to R. Then we can say that A is not related B by R. So that is, we are going to use with the symbol just like this. A is not related B by R. R is called a binary relation. R is called by binary relation from A to B. Since the elements of the set R are ordered pairs, if we use the term relation means it is automatically a binary relation. See, the relation, if you are going to mention, suppose if it is a unary relation, then the relation is defined from the set to itself, then it is known as a unary relation. A relation is defined from one set to another set, then it is a binary relation. So if you are not going to mention whether the relation is a binary relation or unary relation or some other relation, then it is automatically understood that the relation is a binary relation. So now let us consider the example. So here I am just taking the A Cartesian A cross B as like this, set of all ordered pairs. The first element is a member in the first set and the second element is a member in the second set. So set of all ordered pairs. So A is one set and B is another set if I am considering. This is known as a Cartesian product. That means we have to consider all the ordered pairs. Now let us consider the relation. I am taking the relation as the first element is less than the second element. The first element is less than the second element. We have to consider the relation like this. So now from this is one ordered pair which satisfies this property, and this is another ordered pair which satisfies this property, and this is another ordered pair which satisfies the property, and this is the ordered pair which is not satisfying. This is the ordered pair which is not satisfying because the first element is greater than the second element. So here only three ordered pairs will be there which are satisfying this result. So I am going to consider the relation as 1, 2, 1, 4, 2, 4. Suppose if I am going to consider this relation as, let us say this, x is greater than or equals to y. If I am going to consider a relation is like this, then R is consisting, the first element is equals to the second element. So this one I have to consider, and so I am just taking 2, 2. Then because the first element is equal to the second element and the first element is greater than the second element and the first element is greater than the second. This is another relation. See, the first relation is less than, the first element is less than the second element, and suppose if I am taking the relation is like this, x is greater than or equals to y if I am taking the relation is like this. This is the relation set. And suppose if I consider x is greater than y is a relation, x is greater than y is a relation, then I am not going to consider this. I am not going to consider this. So I can consider only 5, 2, 5, 4, 5, 4. So this is the relation set I am going to get. So the relation is, in general, we can call it as, it is a subset of the Cartesian product of the A cross B, A cross B. Now here, what is the domain and what is the range for any relation? For any relation. So the relation where, from where it is a starter, from which set it is started. That means the element of first elements, A comma B belongs to R. So set of all A's belongs to A is called domain of R, And set of all B belongs to B such that with this property, then this is known as a range. Let us consider, if I am taking this is A and this is B are any two sets, and relation is defined as like this. So it is just 2, 2, 2, 4, 2, 6 like this. Then what are the domains and what are the ranges we have to consider? See here, I am just taking, this is the relation if I am going to consider. Then the domain, what is the domain? Set of all A, set of all elements of A. So the first elements, for the first elements. So here 2 will be there, and here 2 will be there, and here 2 will be there, and everywhere 2. And here it is 3 will be there, and it is 5 will be there. So I can say that this is the domain. And the range, if I am going to consider 4, 2, 4, 6, 10, 6 is repeated, 10 is repeated. So this is the range. So whenever if you are going to define a domain relation, then it has a domain and a range. Let us consider, we are going to take domain and a range. For some example, let us, I am just taking A is one set and B is another set. So list the elements of each relation are defined below, and the domain and range you have to find out. So first one is A belongs to A is related to B, which is satisfying this property. A is related to B, which is satisfying this property. And next, A related to B, which is satisfying this property. Both are odd numbers. Okay. So for this, let us, we are going to consider the first one is, what is our Cartesian product of A cross B is? A cross B is set of all the elements we are going to get. So what is 2, 3 and 2, 4 and 2, 5. Then 3, 3 and 3, 4. Then 3, 5. Then 4, 3 and 4, 4 and 4, 5. These are the elements will be there in the Cartesian product of two sets. Now, here we have to select. A is less than B, where it's satisfying the property. So it is, this is 1. So 2, 3. Then another one is 2, 4. 2, 4 will be there. Then another one is 2, 5. So 2, 5 will be there. And 3, 3 will not be there because 3 is not less than 3. So 3, 4. 3, 4 we have to consider because the first element is less than the second element. 3, 5, which is also going to be considered. And next 4, 3 will not be considered. 4, 4 will not be considered. 4, 5 is going to be considered. So now, what is the domain? So here 2, then 3, then 4. So domain of R is the set of all first elements. The set of all first elements of the ordered pairs in the relation. Then the range is the set of all second elements, 3, 4, 5. So it is 3, 4, 5. This is the first one. And whereas the second one, if we are going to consider, the both are odd numbers. Both are odd numbers. So where we are going to get both are odd numbers? Both are odd numbers means 2 is an even number. We are not going to get. So this is 1 and this is another one. So 3, 3 and next another one is 3, 5. Next here 4 we are not going to get because 1 is 4 is even number will be there. So we have to get this and this. This and this. So we are taking 3, 3, 3, 5 is the relation. Now what is the domain? The set of all first elements. So this is 3. And what is the range? The set of all the second elements of the ordered pair. So 3, 5. So it is a range. So this is the way that we calculate what is the domain and a range. Now let us consider a matrix of a relation. We are going to represent any relation with a matrix, then that is known as a matrix of a relation. Matrix of a relation. So let us consider the set A is consisting M element, B is consisting N elements. Then how we are going to write, how we are going to construct a matrix. Construct a matrix. Of course, A cross B will have M into N ordered pairs. So we are going to get M N ordered pairs we are going to get. So M n numbers. So A cross B, cardinality of A cross B is nothing but cardinality of A into cardinality of B. Cardinality is nothing but number of elements in that set. So A cross B is a set which is having how many elements? That represents cardinality. That represents cardinality. Cardinality of A cross B. The number of elements in A cross B, which is equals to the number of elements in A and the number of elements in B. So which is nothing but M n elements, because it is cardinality of A is M elements and the cardinality of A B is N elements. N elements. Now there are M n elements will be there. M n elements will be there. Then we have to find the relation. Relation is nothing but the subset of A cross B. A cross B. Now, okay, how we are going to construct a relation matrix? How we are going to construct a relation matrix? So here, if AI, AJ, if AI, any ordered pair, if you are going to consider any ordered pair, that means Mij means ith row, jth column element in a matrix. Ith row, jth column element in a matrix. So AI, AJ, which is there in the relation, because the matrix is consisting only here it is a binary matrix, either it is having a 0 or it is having 1. So when we are going to keep 1 and when we are going to keep 0. So for that, any ordered pair AI, AJ, which is a member in the relation, then the corresponding position we have to keep as 1, otherwise we can keep as 0. So Mij is equals to 1 if the ordered pair AI, AJ belongs to R, otherwise it will become 0. Otherwise we have to keep 0. So in this way we are going to get an M by N matrix, that is M rows and N columns. M rows indicates the number of elements in set A. N columns indicates the number of elements in set B. Columns denoted number of elements in set B. Rows indicate the number of elements in set A. Now, whatever the matrix that we are going to get, that matrix is known as a adjacency matrix, or we can call it as a relation matrix, or we can call it as a matrix of the relation. Matrix of the relation. Let us consider one example. So here, this is A and this is B. This is set A and this is set B. So, and R is a relation from A to B defined as like this. Now we have to construct a relation matrix. We have to construct a relation matrix. So, while we are going to construct a relation matrix, so we have to construct a relation matrix. So here, first rows and as well as columns. So rows is nothing but the set of all elements which are there in A. So this is for 0, this is for 1, and this is for 2. So this indicates rows. Rows are nothing but elements of A. And elements of B indicates then the elements of B. Now this is 0, P, 0, P, which is there here. So the corresponding position we have to take it as 1. Next 0, Q. 0, Q is not there. We have to take it as 0. Next 1, P. 1, P is not there. So we have to take it as 0. Then 1, Q. 1, Q will be there. We have to take it as 1. Then another one is 2, P is there. 2, Q is not there. Then we have to take it as 0. So then we just remove these things, and now whatever the matrix we are going to get here, the same matrix is here. So just we are going to write in the another way, just what the elements we are going to write row wise, and the column wise we are going to write the elements of B. Then we can construct a matrix. So this matrix is known as a adjacency matrix, or matrix of the relation, or simply we can call it as a relation matrix. Now, we are going to represent in a pictorial manner. So here it is a binary relation, R is a binary relation, which is defined from the set to itself. Of course, it is a binary, but we are taking the relation from set A to itself. Okay, then how we are going to draw a digraph of a relation? So first of all, draw a small circles or bullets for each and every element of A. And label the circle. Suppose A is equals to, I am just taking 1, 2, 3. Then I have to write one circle, then another circle, and write all the elements and enclose small circle, not large circle. These are all very small circles we have to keep, and we have to label that. How we are going to label? The element itself we are going to write. Okay, so now these circles are called vertices. Okay, or nodes we can call it as. So now the relation, suppose if I am taking the relation, let us say 1, 1, 1, 2, and 2, 3, and the next one is let us say 2, 2. Suppose this is the relation. And if it is a relation will be there, then we have to consider, let us say, in any order we are taking the vertices or the nodes. Then if any, see R is a relation, draw an arrow called an edge from a vertex X to a vertex Y if X, Y belongs to R. If X, Y belongs to R, then we are going to draw a directed edge from x to y. From x to y. Suppose here 1 to 1 is there. So 1 to 1 I am going to represent like this. One edge is leaving from vertex 1 and reaching the same vertex 1. So 1, 1. Next 1, 2 if I am going to consider, I am going to take like this. 1, 2. Starting from 1, node which is passing from the vertex 1 and reaching to the vertex 2. Next 2, 3. Let us, I am just taking like this. 2, 3. Direction. 2 is related to 3, but 3 is not related. See, it is a directed edge. And 2 is related to 3. Then the next one is 2 is related to 2. 2 is related to 2. So this is the directed graph. This is the directed graph. See how we are going to draw? There are some principles. So here draw a small circle. So whatever the elements will be there in the given set A, we have to consider all the elements and encircle with a small circle or encircle or draw a small circles. The number of small circles should be equal to the set of the elements of A and label the circles. And these we are calling it as a nodes or vertices. Nodes or vertices. Now we are going to draw a directed edge from node X to node Y if X comma Y belongs to R. If X comma Y belongs to R. So whatever in that way we are going to represent. So the pictorial representation of a relation is known as a directed graph. Directed graph. Or we can call it as a digraph. Simply we can call it as a digraph. So where the edge is passing through, or the vertex from which the edge leaving is known as origin. The edge is leaving from 1. This edge is leaving from 1. The origin of this edge is 1. The origin of the edge is 1. Or source is equals to 1. Source is equals to 1. Source is nothing but vertex 1. And where it is ends, the edge where it is reaches or where the edge ends is called terminus. Suppose if I am taking E1, what is the origin of the E1 is node 1 and what is the terminus is node 2. And suppose if I am going to consider another node, let us take, I am just considering 3 and 4. Then another one will be there, 4, but there is no vertex which is connected to 4. So 4 is neither source nor terminus. So such vertex is known as a isolated vertex. Such vertex is known as a isolated vertex. So now, up to now, what is a relation, how to construct a matrix of a relation, and how to draw, how we are going to pictorial representation of a relation, that is nothing but a digraph. Now let us consider how we are going to see here. There are some more things will be there. One edge is leaving and one edge is reaching to the same. So leaving from one vertex and reaching to the same vertex. This is we are calling it as a loop. And another one is what is the in degree of the vertex and what is the out degree of the vertex. So number of edges which are reaching to that particular node is the in degree of the vertex, and the number of edges which are leaving from that node, that is nothing but the out degree of the vertex. Out degree of the vertex. So in degree, what is the origin? What is the terminus? What is the isolated vertex? What is loop? And what is the in degree of vertex? And what is the out degree of vertex? Let us consider. We are going to draw a digraph of the one relation. Let us, A is a set and the relation is defined already. Just we are going to take some relation. We don't know what is the relation between the elements of A, and we are going to define one relation. Now, we are going to represent the pictorial representation of a relation is nothing but a digraph. Now, let us see here what are the elements will be there. A, B, C, D. In any order, in any way we can consider A, B, C, D. I am taking, and those are going to be encircled. 4 elements are there in the set, so 4 circles are going to be drawn, and 4 circles we are going to label with the elements of A. Now, A to B. So, there is one directed edge from A to B. This is. Let us, I am just taking this as E1. So, I am just taking this as E1. And next, BB. Another one is BB. So, BB, let us, I am just taking E2, edge E2. Next, BD. So, BD means this is the direction. See, this is from, the edge is starting from B and ending from D. So, it is, let us solve. This is third one, and this is fourth edge. Let us say fifth edge. This is sixth edge, and this is seventh edge. Let us, I am just taking. So, third edge. Next, fourth edge is C to D. C to D. This is fourth. And next, C to, both are C to B and C to D. Now, this is 4. And this is C to D, which is 5. Next, D to A. D to A is 6. And next, D to C is 7. D to C. D to A is 6. D to A is 6. And D to, this is 7. So, we are just drawing an edge wherever the corresponding ordered pair will be there. And A comma B means A to B, you have to draw the edge. Don't draw from B to A. A is related to B only, but B is not related to A. So, the meaning of A comma B is A is related to B only. So, there is a directed edge from A to B only. Now, here, let us consider this as how many loops will be there. This is one loop. Now, what is the in degree and out degree of the vertices? So, vertex A, let us say vertex A, what is the in degree? What is the in degree? In degree means how many edges are reaching to that vertex. How many edges are reaching to that vertex? So, here E6. This is only to vertex A. So, there is no other vertex. So, this I am taking it as 1 in degree. And B if I am considering, this is 1, this is 2, and this is 3. So, I am going to consider this as the in degree of the vertex B is 3. Now, the in degree of the vertex C. What is the in degree of the vertex C is only this is 7, only 1. The in degree of vertex D is in degree. So, this is 1 and this is 2. So, this is 2. Then, the out degree of the vertices. The number of edges are leaving that particular vertex is known as out degree. So, let us take A out degree. What is A out degree is? Only 1. Only 1. And B out degree is? B out degree is? This is 1 is leaving and 1. This is in degree as well as out degree we have to consider. And this is 1 and this is another 1. So it is 2. And C, if I am considering how many edges are leaving. So it is 1, 2. This is also 2. And D is also 1 and 2. So this is 2. So in this way we can calculate what is the in degree of the vertex and what is the out degree of the vertex. Now let us consider the another diagram, another relation we are going to construct, and we are going to represent the relation in the form of a digraph. Let us see this. A is 1, 2, 3, 4 will be there, and relation is given as x is related to y means x divides y. If first number is divides second number, then only such ordered pairs we have to consider. Then write down R as an ordered pairs, okay, relation, and a digraph of the relation, and what is the in degree and out degree of the relation. So now let us consider the element 1. The relation is from A to A itself. A to A itself. So we are going to consider A cross A. A cross A. So 1 is related to 1, 1 is related to 2, 1 is related to 3, 1 is related to 4. Next 2, 1, 2, 2, 2, 3, 2, 4. Next 3, 1, 3, 2, 3, 3, 3, 4. 4, 1, 4, 2, 4, 3, 4, 4. Now, among this, what we are going to get? A cross A is, A cross A is. So we have to write all the things, A cross A. So here it is 1, 1, then it is 1, 2, then it is 1, 3, then it is 1, 4, then it is 2, 1, 2, 2, and 2, 3, and 2, 4. Next 3, 1, 3, 2, and 3, 3, 3, 4. And next 4, 1, 4, 2, 4, 3, and of course 4, 4. This is the ordered Cartesian product of A cross A. Now, in this we have to select. First element divides the second element. 1 divides 1. 1 divides 2. 1 divides 3. 1 divides 4. First element is divides the second element. So, we have to consider 1 to 4. Next, 2 to 2 will be there. 2 divides 2. 2 divides 4. So, we have to consider 2 to 2, 4. Next, 3 will not divides 1. 3 will not divides 2. 3 divides 3. So, we have to consider 3 divides 3. And 4 will not divides 1. 4 will not divides 2. 4 will not divides 3. 4 divides 4. So, we have to consider this. So, now only these elements we have to take, and the remaining we are going to ignore. Remaining we are going to ignore. We are going to ignore this, and we are going to ignore this, and we are going to ignore this. We are ignoring, and we are ignoring this. And this also we are going to ignore. Next 2, 3 also we are going to ignore. So it is not there. So 2, 4 will be there. So now whatever these variables will be there, this will become a relation. This is the relation. So that those ordered pairs we are mentioning. And next, after mentioning all the ordered pairs, that is the relation. That is the relation. Now after constructing a relation, now we have to find out. We have to find out what is the digraph of this. What is the digraph of this? So first one is, so we have to construct. We have to construct. So the digraph. So for that, how many elements will be there? Only 4 elements will be there. So I have to consider 4 circles and label that in any order. We can say, we can write, we can take this not only in this particular order, you can consider in any order. Okay. And now, so the relation, see here 1, 1. So it is 1 is related to 1. 1, 2. 1 is related to 2 like this. So this is E1 and this is E2. This is E1 and this is E2. Next, 1 related to 3. This is not a 1 related to 2, it is E2. And this is E3. And then E3, this is E3 I am taking, this is E4. So this is E4. Then this is 2, 2, E5. Let us say this is E5. And 2, 4, it is E6. E6. And 3, 3, E7. And 4, 4, E8. Like that. There are 5 edges will be there. Now we have to consider that this is the digraph. So wherever the ordered pair will be there, then we have to construct an edge between those two nodes. See, this is a directed graph. It is not undirected graph. 1 is related to 2 means 1, 2 means 1 is related to 2. 1, there is edge should start from 1 and edge terminates at 2. Then there is no edge from 2 to 1. There is no edge from 2 to 1. So in this way we can draw the digraph. Now what is the in degrees and out degrees of the vertices? So in degrees, while we are going to consider 1, 2, 3, 4. What are the in degrees? In degrees means how many edges are reaching to that vertex. So this is only 1. So I am taking 1. Now for 2, this is 1 and this is 1, 2. Now for 3, this is 1 and this is 1, 2. And next for 4, this is 1 and this is another one, this is another one. So how many are there? 3 are there. So 3. Now out degrees of the vertices. Out degrees of the vertices. How many edges are leaving from that vertex? So self loop we are going to consider in degree as well as the out degree. So this I am going to consider 1, 2, 3, 4. All are moving out. So it is a 4. And the next second out degree is 1. Then it is 2. This is 2. And the third out degree is only this one. Only this one. So it is 1. Fourth out degree is only this. So it is this. So in this way, we can calculate the in degree and out degree of a directed graph. And we are going to construct what is the relation. And now how to construct a relation matrix. And of course, now related problems we are not going to take up. Now in the next class, we are going to take up the relation matrices and relation matrix and some more problems, how to construct a relation and digraphs as well as a relation matrix. So today, this session, I am going to stop here. In the next session, we are going to meet. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.